Today we're going to take a look at probability using tree diagrams and tables. We usually use this when we have compound probability, which means we have more than one event. So if I'm rolling a dice and flipping a coin, there are two completely separate things, and we're trying to find the probability of maybe something and or using and or. So here we have find the probability. Remember the capital P, okay, so this P right here, that stands for probability. So we are trying to find the probability of a red, so we're finding probability of red and a car. So we have two spinners. We have red, white, I'm going to guess that's blue and green, and also car and truck. So we are going to use a probability rectangle for this. So I'm going to draw a rectangle. And we have four colors. So I'm going to split this into four pieces. And I'm going to label it red, white, blue, green. And we also have car and truck. So I'm going to split that going down this way. So we have car and truck. Now what I'm going to do is I am going to inside write what we have. So here I'm going to use abbreviations. I'm going to use C for car. So that's going to be C, and this is going to be truck. So here we have a red car, we have a white car, blue car, green car. Over here we have a red truck, white truck, blue truck, and green truck. So we notice that each of these have equal probability. Okay, that is the one thing that's really important to know. Okay, so we have 8 total boxes. So that means that each box is equal to 1/8. So what I want you to get in the habit of doing is going through and listing the probabilities of each one. So we have 1/8 here. So what it is asking us for is red and a car. Okay, so that would be this one box up top here. So the probability of this happening would be 1/8. Okay, let's take a look at the next example. Sammy loves purple, pink, turquoise, and black, and has a blouse in each color. She has 2 pairs of black pants and a pair of black khaki pants. If she randomly chooses one blouse and one pair of pants, what is the probability she will wear a purple blouse with black pants? We're going to try to do this one using a tree diagram, just to show the difference between the two. So for a tree diagram, we're going to take a look at the first item that could happen. So we are going to be choosing a blouse, and we have purple, pink, turquoise, and black. So I'm going to split my tree into 4 parts. Okay, and I'm going to label everything. So we have pink, we have turquoise, and I forgot purple, and we have black. Okay, so those are all the choices that could happen with our first picking of something. Then we're going to pick something else. So now we're going to pick a pair of pants. And we have black and khaki. So even if I chose the pink, I could choose the black. I'm going to use B and K for black and khaki. If I chose the turquoise, again, I could get a black and a khaki. Purple, same thing. And with the black, black and khaki. Now, if we take a look at all these, there are 8 total possibilities because I could have gotten pink with the black or khaki and the same thing. So each one of these is equal to 1/8. So just like what we did with the rectangle, I'm going to label all of my probabilities. Remember, all probabilities have to add up to 1. So if I would all add these up, we have 8/8, which is equal to 1. So the question is asking, what is the probability that she's going to wear a purple blouse with black pants? So here we have purple, here we have black, so that probability right there is 1/8. So the correct answer here is 1/8. Okay, question number 3. What is the probability Joanne will win a chocolate double scoop? Okay, so we have, it looks like 3 kinds of ice cream and 4 types of ways that you could serve the ice cream. So I'm going to draw a probability rectangle for this. Okay, so we're going to draw a rectangle. Should have left more room up at the top. Oh well. So I'm going to split this into 3 for the 3 kinds of ice cream that we have. We have chocolate, vanilla, strawberry. And now we have 4 ways of serving it. We have single scoop, double scoop, soda, or sundae. So I'm going to write single scoop as SS, double scoop, DS. Let's do SO for soda and SU for sundae. So what I'm going to do now is I'm going to write, so we have so a chocolate single scoop, chocolate double scoop, chocolate soda, chocolate sundae. And I'm going to go through and list everything. It's really important that we get in the habit of doing that. That way you can visually see which ones match the criteria once we start answering the questions. I know it might take a little bit of extra time, but it will help you get the right answer. So we want to get used to doing that. Okay, so we also know that each one of these, we have 12 total boxes. Okay, so each one of these is equal to 1/12. Okay, so each one of these little boxes, if we would add them all up, we should get 12 over 12, which simplifies to 1. So the first question, what is the probability of getting a chocolate double scoop? So that is right here. I'm going to put a circle around that one. Okay, we have only 1 out of 12 total boxes, so the probability of that happening is 1/12. Okay, the second part, it says what is the probability that she's going to get chocolate or a strawberry sundae? This time I'm going to put a triangle in those boxes. So we are going to look for a chocolate sundae, which is over here, so I'm going to put a little triangle there, or a strawberry sundae, so that is also down below. So out of this one, I have 2 triangles, so we have 2 out of 12 boxes. And remember, we always want to simplify our fractions, so that would convert to 1/6. The last part, it's asking what is the probability that we are going to get a chocolate double scoop, okay, or a chocolate sundae. I'm going to put a star in those boxes. So first one we are going to take a look at, we're going to have chocolate double scoop. So here's one, so I'm going to put a star. And a chocolate sundae over here, that's also a star. I like using different shapes for each of the different problems so that way I don't get confused. So here we have 2 stars, so we have 2 out of 12. And like we did in part B, we need to simplify, so that would be 1/6. Okay, number 4. Jay is looking in his closet trying to decide what to wear. He has 2 red t-shirts, 2 black t-shirts, and 3 white t-shirts. He has 3 pair of blue jeans and 2 pairs of black pants. Okay, so we're going to make a probability rectangle for this one. Okay, so I'm going to draw a pretty big rectangle because we have lots of different items. So we have 2 red shirts, 2 black shirts, and 3 white shirts. So we need a total of 7 shirts. So 1, 2, 3, 4, 5, 6, 7. And we have 3 pairs of jeans and 2 pairs of black pants. So I'm going to split this going across. So 1, 2, 3, 4, 5. And I'm going to label everything. I'm going to abbreviate it. So R for red. We have 2 pairs of black and white, white, and white. Okay, and then we also have jeans, 3 pairs of jeans. I'm going to use J for jeans and a B for black pants. Okay, so now I could go through and I could list out like red shirt with jeans and everything. Just because I know what's coming up for this problem, I'm just going to stick with drawing in some symbols here. So part A, it's asked, what is the probability of his randomly choosing a red shirt with jeans? So I'm going to put a star in all those boxes. So red shirt and jeans. They're going to get a star. So if we take a look at how many boxes we have total, okay, we had 7 types of shirts, 5 pairs of pants, so 7 times 5 is 35. And here we have 6 favorable outcomes divided by 35 total outcomes. So the probability of him getting a red shirt with jeans would be 6 out of 35. Okay, part B, what is the probability of his randomly choosing an all-black outfit? So here we have black pants and a black shirt. I'm going to put a check mark in those boxes. So we're going to go across to black shirt and down to black pants. And here we have 4 out of 35 boxes. Again, I like using different shapes for each one. If you can use different colors when you're doing it, that even works better. And part C, which combination out of all of his possible choices has the greatest probability of being randomly picked? So how can you tell? Well, the one that has the best chance of being chosen for shirts would be white shirts, because I have 3 of them up here. Okay? And the one that I have most of for the pairs of pants would be jeans. So I would think that the white shirt with the jeans would be the one that occurs the most often. I am going to put a circle in each of those boxes. Okay, now if I look at that, we have 9 boxes. There's no other way that I could get 9 boxes. Red jeans, red shirt with jeans, that has 6. Black with jeans, that only would have 6. Red shirt with black pants would only have 4. Black pants with black pants has 4. And white shirt with black pants has 6. So the combination that has the best would be white shirt and jeans. Okay, so hopefully you have gained a little bit of more information about using probability tree diagrams and also tables. So hopefully now you will be able to successfully answer the questions that we're going to be doing in class.